This is another problem that I'm just going to give a hint on because my class is asking for a hint on this one. Or they actually want the answer, but I'm just going to give them a hint. So we have acceleration right here. It says the acceleration of an object is given by this function, and the initial velocity is given by this initial number right here. So if we want to find the equation v of t, we have to realize that if I integrate a of t dt, I go to v of t. So that means this one I need the indefinite integral a of t dt, and whatever that turns out to be, that's going to produce v of t with a constant attached. And then you're going to use this information here to find c. Solve for c. Plug in 0 for t. The output is minus 15. You can find c that way. Now, this is total displacement, so that's speaking of s of t. So we learned from a previous problem that if I integrate v of t dt, I actually will get my total displacement. And that's just going to go over the interval from 0 to 3. Total displacement. And then to find the total distance, the difference is you have to figure out, okay, what part of my graph is a v of t is above the axis and below the axis, separated by that, then add the actual areas. Remember, total displacement takes into consideration where the area is. In other words, if it's under the axis, it's negative. And that calculates into the total number there. But if you're going to do total distance, you have to ignore where it is, ignore that negative, and just add subsequent areas. So that is your hint to do this problem. And you should be able to finish it based on this information and the information from the other problem.